The vast majority of the papers we discuss are about pushing technology forward, a new way to solve a problem, a new trend in an industry, or a new tool that hasn't found its use case yet. But every once in a while, we come across a paper that is doing the opposite, a paper that's saying, wait, turn around, we're headed in the wrong direction. Today's paper is in that latter group. The authors are making the argument that diffusion models are being misused. They say that diffusion models are being treated as if they're upgraded GANs, but in reality, they're fundamentally different. And that difference makes them unsuitable for some of the use cases to which GANs were being applied. It's an interesting case that they're making, and it gives us an excuse to dive into both GANs and diffusion models, learn how they work, how they're the same, and how they're different. Once we have that foundation, we can examine their argument and try to understand why they're saying that diffusion models should not be used for some specific cases. GANs, generative adversarial networks, came out first, so let's start there. Actually, let's start before that point. Before GANs, generative models relied heavily on variational autoencoders, that's VAEs, and restricted Boltzmann machines. VAEs are a type of probabilistic model. They generate images by compressing existing ones into a simpler representation, and then reconstructing them while adding a bit of randomness to make new variations. Boltzmann machines, on the other hand, are energy-based models. They generate images by gradually refining random noise into something that looks like real data through trial and error.